Hello everyone, this is again your junior high school math teacher, and I'm going to discuss about quadrilaterals under week 1 of your third grading period in Mathematics 9. So the following objectives are: number 1, describe the different kinds of quadrilaterals. Number 2, determine the conditions that make a quadrilateral a parallelogram. So in this material, you would be able to determine the conditions that make a quadrilateral a parallelogram. Now let us begin with the word quadrilateral. In geometry, it is simply defined as a closed plane figure or a polygon with 4 sides. In other material, quadrilateral or quadrangle or quadrigon is defined as a closed plane figure of 4 line segments joined together at their endpoints. Quadrilaterals are classified according to the number of parallel sides. And for you to clearly understand this statement right here, on the next slide, I'm going to show you the tree diagram of quadrilaterals. We begin with the so-called general quadrilateral. A general quadrilateral is defined a quadrilateral as a quadrilateral with no pair of parallel sides. And under this quadrilateral, we have three different classifications or three different kinds. And these are the trapezoid, the parallelogram, and kite. As what I said a while ago, quadrilaterals are classified according to the number of parallel sides. Okay? Now, under general quadrilateral, let us consider first the trapezoid. Okay? Now, we put some details on each of these three quadrilaterals. Okay? The identical arrowheads on the opposite sides indicates that these opposite sides are parallel. Same thing with uh, those markings on the parallelograms, on the sides of the parallelograms. Okay, the slash marks, the identical slash marks on the two sides indicates that these sides are congruent. Separately, these two adjacent sides are also congruent. Okay, so we go back to the trapezoid. It is simply defined as a quadrilateral with exactly one pair of parallel sides. As indicated by the arrowheads, we only have a pair of opposite sides that are parallel. And we can find this pair of parallel sides on the trapezoids, on the trapezoid. So the other pair are non-parallel sides. Okay. Now, for the parallelogram, it is defined as a quadrilateral with both pairs of opposite sides parallel. So this is the first pair of parallel sides and another pair or the second pair of parallel sides. Obviously, from the word itself, parallelogram, we take the root word which is parallel. So this is the reason why this quadrilateral is called the parallelogram, because both pairs of opposite sides are parallel. And as for the kite, it is defined as a quadrilateral with two distinct pairs of adjacent congruent sides. Now, this is the first pair of adjacent congruent sides, and this pair is congruent. Separately, for the second pair of adjacent sides, it is this second pair of sides are congruent. Okay? So So that is the kite. Next, under the trapezoid, we have a special kind of trapezoid, and we call it the isosceles trapezoid. Now, what makes this isosceles trapezoid different from an ordinary trapezoid? Of course, it has a pair of parallel sides, but you will notice that the non-parallel sides here are actually equal in length as indicated by the slash marks. Okay, one for each of these non-parallel sides. So this is the reason why this trapezoid is called an isosceles. Okay, so this is the definition. A trapezoid with congruent non-parallel sides. By the way, we call the non-parallel sides of a trapezoid as legs, while those parallel sides are called the bases. Okay, please take note of that. Now, what about the parallelogram? Okay, the parallelogram is classified into two kinds. Okay, under the parallelogram, we have the rectangle, and the other one is the rhombus. Now, for the rectangle, it is defined, okay, as indicated by the arrowheads, meaning that either rectangle or rhombus are also parallelogram. Actually, a special parallelograms. These two are special parallelograms. Now, for the rectangle, it is defined as a parallelogram with four right angles, as indicated by small squares from all four corners. Okay? So, it is a parallelogram with four right angles. And as for the rhombus, it is also a parallelogram but with four equal sides, as indicated by a slash mark from each of these four sides. Okay? So, four sides are equal in length. Okay? Yun ang ibig sabihin ng mga slash marks. Okay? Now, there is actually another third type or kind of parallelogram. And this third special parallelogram possesses the property or the characteristic of a rectangle, and at the same time the characteristic of a rhombus. Okay? So this third type or kind of parallelogram have four right angles and at the same time four equal sides. And obviously, I think you are familiar with it. We call it the square. Okay? As indicated by four small squares at the corners and at the same time with identical slash marks from those four sides. Okay? So this is a square, a parallelogram with four right angles and four equal sides. Okay? And with that, if you have no question about uh, the family tree or tree diagram of parallelograms, I think we now go to the next slide. It is actually an activity. Okay? So I think I'll be giving you at least 5 minutes to think about the answers to all 15 items. So all 15 items are statements. So each statement you determine whether it is always true, sometimes true, or never true. Okay, so time is up. It's time now to reveal the answers to these 15 items. You may answer AT for always true, ST for sometimes true, or NT for never true. Okay, here goes. For number 1, a parallelogram is a quadrilateral. The answer is always true for AT. Number 2, a quadrilateral is a kite. So the answer is sometimes true for ST. Number 3, a trapezoid is a kite. So the answer is never true. 4, a rectangle is a parallelogram. The answer is always true or 80. Number 5, a rhombus is a square. So it's sometimes true. Number 6, a square is a rhombus. It's always true. Number 7, an isosceles trapezoid is a quadrilateral. It's always true. Number 8, a kite is a trapezoid. Never true or NT. Number 9, a rectangle is a rhombus. The answer is never true. How about number 10, a square is a rectangle. It's always true or 80. Now we only have 5 remaining items. For number 11, a parallelogram is a square. Sometimes true. Number 12, a square is a parallelogram. Always true or 80. Number 13, a trapezoid is a rhombus. Never true. 14, a rhombus is a kite. Never true. And finally, 15, a rectangle is a square. Sometimes true. So if you don't have any more question, we now go to the next slide. Another activity. So this is activity number 2. Now from the direction, you identify the following names. And from each name, you need to determine what geometric figure is that name from each of the 15 items. Again, what geometric figure with that name from a particular item. So let's begin with number 1. Or better yet, I'll give you enough time to think about the answers from these on these 15 items. Okay, I think everyone is done answering this activity. So let us now reveal the answers. Okay, number 1. What geometric figure do we have with the name A, B, C, D? So the answer to number 1 is quadrilateral. Now what about a pair of segments? Segment AC and segment BD. Where can we find those two segments? These are the segments. And obviously, what do we call this segment from this quadrilateral? We call it diagonals. Okay? Next, we have a pair of angles in number 3, angle A, together with angle C. What do we call this pair of angles? If your answer is opposite angles, so that is correct. That is correct. Number 4, another pair of angles, angle A and angle B. Okay, so angle B, angle A, the opening of this angle, and the opening of angle B. So these are the two. What type of angle pair do we have in number 4? We call these angles consecutive angles. Next, number 5, segment AB and segment DC. Where is it? This one. Segment AB and segment DC. What pair of sides do we have for number 5? If your answer is opposite sides, you are correct. Next, for number 6, segment AB and segment BC. Where are these two from this quadrilateral? Actually, ito yon, no? Segment AB and segment BC. Anong pares ng sides ito? If your answer is adjacent sides, you are correct. How about number 7? How about quadrilateral EFGI? Where is it? Okay. Quadrilateral EFG. Okay, did I say EFGI? No, it's EFGH. EFGH. Okay. Now look at the markings on the sides. One pair of opposite sides has identical arrowhead markings, and the other pair are identical slash marks. Now, what kind of quadrilateral do we have here whose name is quadrilateral EFGH? If your answer is isosceles trapezoid, you are correct. Now we go to number 8. What about a pair of segments, EH and FG? Where is it? EH and FG. So obviously, from the trapezoid, these are the non-parallel sides. Of course, I can consider the answer opposite sides, but when it comes, but since we're talking about this trapezoid, what do we call this non-parallel parallel opposite sides? In number 8, we call these two sides as legs. Okay? About number 9, segment EG, ito yun, and segment FH. What are these sides? If your answer is diagonals, you are correct. Okay? Now, what about this segment? Segment EI. Ito yun. Now, you will notice that this segment is perpendicular to this horizontal side of a trapezoid, or the base. Okay. Now, this segment forms a right angle with segment HG. Okay? So, what do we call this angle? What do we call this segment, rather, no? This one. So, the answer is altitude. Okay. Next, we have a pair of angles here. Each of these two angles uses 3 letters. Now, where can we find that this angle EHG? This one. Angle EHG. This one. Okay? And the other angle FGH, this one. Angle FGH, this one. Okay. Now, you will notice that, of course, we can consider this pair of angles as what? Consecutive angles. But since, again, we're talking about trapezoid here, and these angles are actually what? Found on both ends of the base. So, aside from calling this pair of angles as consecutive angles, we can call them also, or more proper, as base angles. Now, since this pair of angles are on both ends of one base. Yan. Number 12, Angle HEF, this one. So this is the angle together with angle GFE, this one. So if the answer to number 12 is the same as in number 11, base angle, excuse me, you are correct. Okay, number 12, the answer is also base angles. And for number 15, another name of a quadrilateral, quadrilateral EFGI, this one, EFGI. Now, what kind of quadrilateral we have here, whose name is quadrilateral EFGI? If your answer is trapezoid, you are correct. Then for number 14, angle EIJ, obviously there is a small square at the corner. What do we call this angle? In number 14, it's right angle. And same thing with number 15, angle EFJ, this one. It's also a right angle. Okay, so if there are no questions, we now proceed to the next slide. Okay, I think you are very much familiar with the different kinds of quadrilaterals as well as some terms, pairs of segments and angles related to quadrilaterals. We are now on the next part of this topic. Or better yet, okay, wait lang. This is actually an activity. Now, as I said a while ago, we are done with the discussion of the different kinds of quadrilaterals, as well as some related terms, particularly pairs of sides or segment and pairs of angles. We now go to the next part of this video, and that is the different conditions of uh, of a quadrilateral as a parallelogram. Okay, so let us consider this slide. Aside from the definition of a parallelogram, which is a quadrilateral having two pairs of parallel sides. Now, any of the following conditions can be used to prove that a quadrilateral is a parallelogram. And these are the following, okay? Number one, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Number two, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Third, if any consecutive angles are supplementary, then the quadrilateral is a parallelogram. Fourth, if the diagonals bisect each other, then the quadrilateral is a parallelogram. And finally, the last condition, the fifth one, if a pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. Now, let us take some examples. We have here a given quadrilateral whose name is quadrilateral ABCD. And you will notice that in this quadrilateral, we have two diagonals, and those are segment AC and segment BD, intersecting at point E. So let us try to answer this example. Okay. And particularly this question, is quadrilateral ABCD as a parallelogram? And whether your answer is yes or no, you justify the your answer. Okay. So we have four items under number 1. Let us take letter A. From letter A, the condition is that segment AB, this one, is congruent to segment DC. And also, segment AD is congruent to segment BC. Now, with this given condition in letter A, is this quadrilateral a parallelogram? Now, if your answer to letter A is yes, you are correct. And the reason is that both pairs of opposite sides are congruent. Now, these are the mathematical statements, and we verbally transform this to this one, statement, verbal statement, okay? Next, how about letter B? Segment AE, where is that segment AE? This one. Is congruent to segment EC. And segment DE is congruent to segment EB. Okay. So with this condition in letter B, we go back to the question. Is quadrilateral ABCD a parallelogram? Yes or no? If your answer is yes, you are correct. And what is the reason? The diagonals bisect each other. Okay. Next, how about letter C? Segment AB is parallel to segment DC. This one. And from the other pair, segment AD is congruent to segment BC. So, with this given condition in letter C, is quadrilateral ABCD a parallelogram? Yes or no? Okay, let us first analyze letter C. Okay, we have here segment AB, which is parallel to segment DC. Okay. Now, if we try to analyze letter C, okay, binanggit lang, binanggit lang dito na segment AB is parallel to segment DC. Pero, hindi sinabi na congruent sila. So, there is a possibility that one of the two sides, although they are parallel, one of these two parallel sides is longer than the other. Probably, DC is longer than AB. Posible na si letter D ay mas mahaba at nandito yung D. Okay? Ayan, nandyan si letter D. Wala dito. And look, segment AD is congruent to segment BC. Dito naman sa isa pang pares ng opposite sides, sinabi congruent lang. Pero hindi sinabing parallel sila. So meaning, itong AD na to, malamang ang position niya pa ganito. Nandito si D. So if you try to imagine the shape of this quadrilateral, okay? As I move the pointer, you will notice that the shape of the quadrilateral is not a parallelogram, but what kind of quadrilateral? If this is where we find D, it's a trapezoid. Therefore, the answer to letter C is no. The reason is the quadrilateral can be a trapezoid. Okay? Next. How about letter D? Angle A plus angle B equals 180 degrees. And at the same time, angle B plus angle C is also 180 degrees. Now, as you remember, last time, we discussed the different pairs of angles in a quadrilateral. Now, what do we call a pair of angle A and angle B? This one. And also a pair of angle B together with angle C. Now, if your answer is consecutive angles, you are right. Now, you will notice that if we take any two consecutive angles, you will notice that the sum of their measures is 180 degrees. And this can only happen in what? Parallelogram. Okay? So, therefore, if this is the condition in letter D, we can answer again the question, is quadrilateral ABCD a parallelogram? Yes. And what is the reason? Any two consecutive angles are supplementary, meaning two angles whose sum is always 180 degrees. Okay? If you don't have any question, we go to the next slide. Okay, here we are asked to find the values of x and y so that the given quadrilateral is a parallelogram. Now, this is the given quadrilateral, and it is already assumed that this quadrilateral is a parallelogram with some labeled measures of segments or sides. Okay? So, if this is a parallelogram, we can apply a certain condition associated with uh, the sides of this quadrilateral. And what is that particular condition? Here goes. So, if both pairs of opposite sides are congruent, then quadrilateral ABCD is a parallelogram. So, this is where we can uh, form the equation or set up the equation, and that in order to solve for x and y. Now, solving for x, now since in a parallelogram, both pairs of opposite sides are congruent, we can therefore say that segment AC is equal to segment BD. Yun. And with this relationship of the opposite sides, we can plug in the equivalent length of AC and that of BD. Substitute. So AC is what? 5x minus 2, which is equal to BD, whose equivalent value is 3x plus 4. And at this point, we have just formed what? Linear equation in one variable. So solving for x, transpose 3x to the left and negative 2 to the right. So at this point, the equation is 5x minus 3x equals 4 plus 2. So we combine similar terms. So we have 2x equals 6. So we divide both sides by 2. Your x is equal to 3. So ito yung sagot. Okay? Next, for the value of y, we set up the relationship between the opposite sides. So these are segment AB equals segment CD. This one. Then, substitute the equivalent of each segment. So the equation becomes what? 2y plus 5 equals 4y minus 9. So another linear equation in one variable, which is in terms of y. So all y terms are isolated on the left side, and all those constant terms are isolated on the right side. So we do some transposition of terms. So we have 2y minus 4y equals negative 9 minus 5. So the equation, if we combine similar term, will be negative 2y equals negative 14. And we divide both sides by negative 2 to eliminate negative 2 on the left side. Therefore, the equation becomes what? Y equals 7. Okay? So, here we have y. We have already solved for y, and that is equal to 7. And for x, it's equal to 3. So, these are the answers. So, if You don't have any question? Now, this is where we end our discussion, and we'll see you next time.